Hi, my name is David Edwards. Welcome to this video about soil colour. Okay, this video is one of several in the series which actually explains just typical ways we describe and therefore come to understand soil profiles. So knowing something about the properties of soils tells us something about the way they're formed, perhaps how useful they may be, limitations, good features, bad features, etc. If you look in the profiles behind me, so these are soils that have been dug up in the field, glued together and mounted on these boards. If you look at these profiles, what you'll see is that they obviously all have quite different colours to each other. Some are much more red, some are much more yellow, some are dark, some are light. And of course that varies down through the soil profile as well. So that tells us something about what's going on within the soil profile and the very nature of the processes at work there. So, we therefore need to describe soil colour as one of our key features of the soil. To describe soil colour, there's a variety of different ways we could use to do that. There are many ways that we can combine colours together, and the whole nature of how we define colour and actually how we represent colour is a science unto itself. But I think most people are aware that there's typically RGB, so red, green, blue, or RYBs, red, yellow, blue type combinations that are often used. Some people would appreciate, of course, on their printers. Most people print with things like inkjet printers these days and so forth. And you normally have a CMYK colour palette that are used to make the printing there. The cyan, the magenta, yellow, and the black, or the key, as it's referred to as the K. Well, for soils, we tend to use what's called a Munsell colour. And so the Munsell soil colour system is just, again, one of several colour systems that we could use. It was developed by Albert Munsell in the early 1900s, so the early part of the 20th century. And why it's popular with soils is because it was adopted by the United States Department of Agriculture as the official soil colour technique somewhere in the 1930s, since the 1930s. So in Australia, we've also followed that lead, and it has adopted it as the main way of describing soil colour. So to describe soil colour using the Munsell system, you obviously will need a Munsell soil colour book, and I'm holding one in my hand here. So these are soil colour charts, just like normal paint chips you would see in a paint shop. They're very highly quality controlled though, and there's a description for each of these chips. Now what we have is the grey, bluey grey type colours to start with, and these are common in many of our estuarine sediments and so forth, and the things that are lacking oxygen quite in reduced environments. As we work through the colour charts, we'll see it actually goes from redder looking colours, and this isn't the full set of charts, it's just the standard ones that we use for many of the soils in the areas around the university here. And of course then we go to slightly less red, and then on to more yellow looking colours as we work our way through the charts here. So as we go further into it, you can see these are now looking much more yellow, and indeed the last couple here look very yellow compared to the ones that are much more red at the start. And I'll just go back to the start to show that contrast, so you can see the difference there. Now when we define the soil colour here, it's not in terms of mixtures of cyan, magenta, yellow or black. It's actually in terms of properties that we refer to as the hue. So the hue is what we just saw there as I went through the book. It's the redness or the yellow hue. The value, which is the lightness, so the value tends to run from much darker down the bottom to much lighter at the top. And the chroma is the purity of the colour or the intensity of the colour. So the colour is much more intense here on the right-hand side, and it's much less intense here on the left-hand side. So they tend to be dominated by the blacks down the bottom corner here and the white colours up the top, and you can see the colours are much more intense and more saturated. If we work across one particular row here, you can see the increase in the colour intensity as we go away across. So you may also have some of these similar type of things on your computer screen or a television where you can change the contrast and the brightness and the colour intensities as well. So hopefully most people are familiar with many of those concepts. So if we were trying to describe soil colour, we'd have to think about how we could apply that to use this to actually describe the colours that we see in any particular soil profile. One way would be to take the charts out, and again, if you look at it here, you can see there are holes. So I'll put it against my shirt so that shows up. There are holes in the actual charts, and it allows us to actually see the soil colour through that way. We could maybe make some comparisons down through the profile, and that could be done. But typically what we tend to do is take a sample from the profile, which I've spoken about in a previous video, and then we'd have that small sample which we would put next to the chart here and allow us to actually make some assessment of its colour. Now there's a few things we need to think about here as part of taking these particular samples or actually deciding upon how to determine the colour. One you should appreciate is it's going to look different according to the types of light. This is filmed indoors, and there's an LED light which is lighting me up here, as well as the fluorescent lights above me. So that's going to look different to outdoors. So that's going to affect what we see. In the lab here, there's lots of orange on the cupboard doors. You can't see that in this video, but believe me, much of the lab actually has orange doors. And so that means you actually end up with quite weird looking colours as a result of that, in terms of the way that puts a bias in my eye. So normally what we say is that you should be standing with the colour chart a certain distance, so typically a good mid-arm's length away from your body. You should be in a relatively overcast sky, so you don't get flare that also affects what's going on, and that will give you the best way of determining the colour. But I'm going to run through it in this video in a lab setting, just so we get the practice and understand what we need to do as part of that. Okay, so we're thinking about describing soil colour. That means we're going to be handling samples of the soil, and if I was out in the field, I'd be wearing normal clothes suited for field work, so probably an old shirt and pair of jeans and so forth. In the lab, that means we'll definitely be putting on a lab coat. So, seems crazy putting on a white lab coat, of course, to get it all dirty with soils, but it at least protects our clothing from getting stained and damaged in some way. So we put our lab coat on and we make sure that we've got it buttoned up so that we don't end up with any nasty accidents and stained clothing. And it does have to be great quality, the lab coat, in terms of acid proof and so forth. It's only just to stop some stains. Alright, so how do I look? Good? Thank you. It should be obvious that this is a much redder looking sample than this one here, and this sample here is a much darker looking colour, and it's actually got more of the yellow tones in it when you actually get down to it in some way. Now these were collected in the field as part of a first year field trip, and they obviously have dried out when they've come back to the classroom, and you can see they've formed up sometimes in their own little aggregates and so forth. Now we could actually take the colour of these aggregates like that, but we actually typically take a moist colour of soil rather than a dry colour of soil. There's a variety of reasons we do that, but there's one most obvious practical reason for that. Can you think why we would normally do a moist colour versus a dry colour? It really should be bleedingly obvious when you've actually thought about it for a minute, but take a minute to think about it. There'll be a question on that at the end of the video. So for the moment, just trust me that we are going to be doing mostly moist colours. We also take dry colours at times for certain tests, but I'll do moist colours in this video. So neither of these two bag samples are very useful because they've got very dry samples in them. But in the tradition of all good cooking shows, here's some samples I prepared earlier, and these actually have been soaking in water, and so they are moist. Now note that if you actually moisten up any sample, it's going to always look a little bit darker. So a moist sample always looks darker than a dry sample. So remember that when you're thinking about things like the soil profiles behind me as well. Potentially that the difference in the colours as you work down through the profile in the field, if you're actually out in a paddock rather than the lab here, that difference in the colour may just be a function of moisture content. So just be aware of some of those things that can happen. Now, as we said, you can see usefulness for the lab coat straight away. As we said, there are various ways we can describe the colour, and we're going to use this Munsell colour chart. So remember, it's also sort of three-dimensional here, so you can see there's two coordinates here in terms of the value and the chroma. But you can appreciate these really, the pages are parts of a sphere. All right, so if I sort of laid it out like that, and they're parts of a sphere in that way. And so any neighbour, if I give a value of this particular chart, any neighbour on this particular sheet that I may be using here also is a neighbour to the sheets before or after it. So they're typically coded, the pages here, in terms of the primary hue. So I've gone to 10YR as the sheet here. Now, that means it's 10 units of yellow and a bit of red thrown in as well. Now, when we go to view, do soil colour, there's some things to remember. One, it's no good doing soil colour if you're in, say, a group and you're colourblind. Typically more males are colourblind than females. It's normally a blue-green colour blindness that they have. So if you are colourblind, maybe you should be offering to do one of the other soil tests as part of your group. I'm going to take a guess and say that this particular soil I've got falls within this particular chart sheet here, which is the 5YR, and see how we go. So what, as we said before, is you'll notice that there are certainly holes here, and again, they probably don't show up so well now, but if I do it like that, you can see it. There are holes, and so you can actually place a sample of the soil. So here's a moist sample of the soil, and I can place that behind those holes to see what colour matches best. And it's not that hard a task to run through and see which of these gives the best match. So let me just have a bit of a play with that and see which one looks the best. So if you'd said 2.5YR46, it looks like it's a pretty good match. Or if you'd said 5YR46, it also looks like it's a pretty good match. So what does that colour tell us? Because we just said it was a 5YR46 as the colour. Well, what the colour tells us when we look at it here, 5YR was the hue, so we write it down as that, 5YR. And then we actually write the value, okay? So again, remember the value is the lightness, how dark or white it is, and then the chroma. And we put a backslash between them. So it's 5YR, and then we put a value of 4, backslash, and then 6 for the chroma as well. If you look at that in terms of how it's described on the Munsell soil colour chart, it actually just comes out as yellowish red, which doesn't tell us very much at all. And indeed, I could have said that was simply a yellowish red soil, but that wouldn't tell me very much because there are several soils on both this colour chart, this page of the colour chart, and others that are described as yellowish red. But by saying it's a 10YR46, anyone else in the world can actually look that up and actually understand exactly what colour we're talking about with the soil. So it becomes an important diagnostic tool. As I said, there are some soils will be actually much more yellow, and so you can see here, this is one of the soils also taken off one of our first year field trips, and again it's been wetting up for a while. And you can see this one looks much more yellow in terms of its colour than the one we just had. So I'm going to be going to a different sheet to start with, and it's probably going to be something much more in the 10YR, 7.5YR range. So I'm going to turn this to 10YR and have a look with that particular one. 10YR53 is the closest match to that one. So it's much more yellow, as you can see it's in a colour because it's a much higher value of yellow-red compared to the 5YR on the previous one. And it also has much lower value for its chroma, so much less intensity of colour. That's fairly obvious when you look at it in terms of one which was, 4.6 versus 5.3. So very big differences. You can see much more intense colour on the red sample here versus what we have on the more yellow one. So that's the simple act of doing a soil colour. Now again, it's something which maybe you need to confer with other people when you're doing it. Don't just trust yourself if you're unsure. Again, remember to flip backwards and forwards through the colour charts as well as look at the samples all around one particular page as well. Also make sure again you're working on moist colours. Have you thought why we do that yet versus dry colours? And also make sure that you don't smear the soil. So don't get a sample like this. You notice I've tried to keep the soil intact as a little lump. We don't get a smeared component of the soil because that will often change the overall impression of the colour that we get. And indeed, there may be little features and little separate colours that may be little extra bits of orange or yellow or whatever that we need to describe as part of the soil as well. For the moment, we're just worrying about whole colour. Okay, I hope you've learnt something from this video, and again, there's some questions to answer at the end in response to hopefully what you've taken away from the video, and good luck doing your soil colours in the lab.